yesterday I had 33 kilograms in 3 boxes of radios delivered that I've bought from someone, and nothing to do with eBay. And these are scrap business radios and a few CB radios as well. I want to do some of the business radios, those of which are repairable. I want to put some of them on to amateur band. They're only 2-channel tape 500s. They're capable of 25 watts, and they do have some uses. I understand there's some high band ones which will go on 2 meters, and some low band ones which will go on 4 meters, and that's very, very useful. There's not much available on 4 meters, and I'm hoping there could be the odd UHF one, because that's where my interests really are on amateur radio. So one of these CB sets that's in here is a DNT B40, and yesterday we did the Radiotechnic RD852, was it? Which is the same in us, because it's basically the same as a DNT M40, but with all the snags sorted out, well, most of them anyway. So basically this is, and it doesn't have any knobs, that's just tough luck, this is a DNT M40, but it's a B40, and the difference is it's got a power supply nailed to the back in its extended case, and these are crystal filtered as factory standard. So that's one of the inadequacies originally. So the first thing is we have a grinning mains plug. And the second thing is I'm going to have to change the capacitors in the power supply before we even start. So I'll sort this out behind the scenes. I'm not wanting to waste video time or your time watching in sorting this plug out. I'm just going to make sure that the terminals are tight for this second, and we've got good leakage circuit breakers here. I'm looking for a screwdriver that is probably on the floor. Yeah, it's the one on the floor. That was predictable, wasn't it? So that was loose. That's very, very loose. So we'll sort that out later. It shouldn't have a 13 amp plug-in, needs to be 3 amp. I don't know whether these have got internal fuses. So we're going to swap this plug. It's an old type without the shrouding, and the cord gripper's failed. So that should be in there and it not gripping the conductor. So it'll do for now on the bench, but before we put this into any use, that will get sorted. So initially we've sorted the loose connections out in there, which is important because it might arc. I'm going to be back to not enough sockets again. So that's lid number 1 off. It does have a fuse at the back. And it's not the captive type, so that's strictly speaking not legal in Europe. They have to stick and stay in the holder, so that is as bad as those band power supplies. So that will need to be changed. In fact, that's a poor show because the law had already come in on that. Well, that's 1.6 amp, that's fine. So that's something which we will need to address again before putting it into any use. So we need to get these capacitors out. You've got these clip down feet, which is a nice thing to put it on an angle. And we'll just unsolder the loudspeaker. I'll tell you what, it's in nice clean condition. That's your crystal filter, which is, as I say, standard on these. And this is why when I did the Radiotechnic set yesterday, I was talking about you've got the 10.24, you've got the transmit mixer with the synthesizer, then you've got the receive mixer, which needs setting with a marker oscillator. So how on earth do you get to that? Well, it looks to me, I think they put this on early on in the assembly, to be honest. This isn't going to be easy. Probably tempted to do the tune-up on the 12-volt power supply and then sort out the internal power supply later. I'll pause the video and see what the task involves. Okay, I managed to get the board out. So I've slipped it off, the screw there and the screw there. Now you can't move this away without dismantling all the aerial socket and that, but what I can do is just tilt it that little bit and a bit more so at this end. So that helps. And I was able to get my screwdriver in and get the top screw out of the pillar, the bottom screw out of the pillar. I've still got the screw stuck in there, that's come out. And your third screw, which is the heat sink, you can actually see it through the hole in there, and Bob's your uncle, as they say. So that's pushed the board out, just pushed the wire to one side. And we've got 2200 Nikkei Den capacitor, whatever that is, and a Ritchie capacitor is 1000 microfarads. So what we're going to be putting in there is going to be smaller, isn't it? Because time's moved on 38 years. That's 25 volt rated, and that's 35 volt rated. So I'll see what we've got. We've got an RS capacitor kit here, and these are ever so expensive. We wouldn't be able to do this if we weren't in business, radio business. I think these cards are 100 quid, but it's a useful and high quality assortment. So 2200 at 35 volts, and 1000 at 35 volts. So they probably cost about £3.50 each. There's far cheaper ways of buying them, but just sometimes we need the quality assurance. So that and that, and then we'll test those and see how well they work. So I'll just unsolder those and fit them. Okay, so 10 minutes later I've done that. So we'll look at these old capacitors I took out. They might be perfectly alright, but I don't want them in there when it's already 38 years old. So we'll look at the 1000 one first. See if any of its microfarads have escaped. Well, that reads alright. Still throw it away. And that reads high, and that's indicative of it starting to fail. Good. So this will now weigh a few ounces less. That was a swine to put in. I had to hold the radio upside down with the screw loaded onto the screwdriver and manipulate it in place, but it's in. Alright. So we're back to that old problem, and that's are there enough sockets here? Yes. Now I've not looked up the chip yet, which that uses. It uses it's an international rectifier L7812LV, and it may not be 1 amp. I'm hoping it's a bit more than that. Right, power. Dead as a dodo. Why would that be? I'm just making sure they put the earth on in this, and they have. So the easiest thing to probably do, I'll put that to the 200 volt range because it's probably about 26 volts, is we hold that on there, see what we've got on the input or output side. We've actually got nothing, so we've got a malfunction somewhere. And this doesn't switch, the on and off switch only switches the 12 volt supply. So whilst ever this is plugged in, the power supply is running all the time on this type of arrangement. So let's see whether we've got AC on that nasty fuse holder. Yeah, well, if we've got an open circuit transformer. Hang on a minute, that's on the DC side. Circuit diagram. Circuit diagram isn't here. Is it on the printer? Yes, it's on the printer. I had the sense, I had some sense for once, to blow up the power supply part of this. So it shows here we've got the mains going in with a fuse, and then it shows another fuse on the secondary into a bridge rectifier and into a 78S12, and we've got the 1000 microfarad and the 22,000 microfarads. And so then that DC goes through a choke in a hope to get rid of a bit of racket, and away we go. That fuse is an internal transformer fuse which will pop at 126 degrees. So the idea is if the temperature of the transformer goes to 126 degrees, which is well beyond boiling point, and starts smoking, then that will permanently fail. So that is the end of the transformer. So it's not a fuse as such. So that fuse, I said, is dangerous, doesn't need changing because it's on the secondary side, and so it doesn't matter. I was assuming it was on the primary side, which would be mains. So that saved me 98 pence. So we should have got AC coming straight out of this transformer into the bridge rectifier. Of course, there's always a possibility that the fuse in the plug's no good. I never thought of that. So if I can get to the terminals of the bridge rectifier, let's see whether we've got AC going in somewhere down there. I can't see anything. Time to unplug it and check that fuse. I wonder if it just happens to have got a duff fuse in the plug, because some previous owner at some point has pinched the fuse out of the plug to put in the wife's hairdryer. Yeah, fuse is okay. Well, I'll tell you what, while we've got this plug-in bit, I'll swap it. I will just say we'll be plugged into one of these hoppy devices so I can monitor the current to see whether it is actually drawing anything. I'm not going to be able to show this on screen because the lead's too short, and where the plug is and where the camera is aren't kind of the same. Okay, so we've now got a new plug on this, and the wires are dressed in such a way, and you can see it's got a 3 amp fuse, that there's always a bit of give in that earth, so it's the last one to pull out if there was a problem. So this, as I say, is fitted with a 3 amp fuse. This is a plug that's come from RS Components, so we should be afforded some quality. So I'll plug it into the hoppy device, which you can't see. And it's now drawing 1.7 watts. So that's good news. Proves the transformer's not open circuit. I'm just going to fiddle with the overhead camera, and I'll just see whether I can swizzle it onto the display. It'll all be upside down and that, but it might be something for you to see. Just one moment. Okay, well, it's not really flickering. It's the camera shutter speed, you know, because these things are multiplexed. So as you can see on the bottom left screen, bottom left display, we've got 1.73 watts being drawn, and at the moment we're at 230.9 volts, and we're doing 49.97 hertz, which sounds fair enough. So that proves to me that this tannoy speaker seems a bit louder than it should be. It should be on volume 1 in this room. I'll turn it off altogether. It was on volume 1. We've got somebody come through on the local UHF 77s repeater, and I don't want to be competing with them. So let's see whether we're getting a voltage out of the actual power supply. So I'll switch the camera back to position 1 if I press the right button. Hey, that worked. Well, we've still got nothing coming out on the face of it. So once again, I'll check the secondary output of the transformer. Where we go into the bridge rectifier. I wonder if that fuse is open circuit. Let's kind of go. So that we know now that's a secondary fuse. So I'll just unplug it from the hoppy device. And we'll just go on that fuse. No, the fuse is fine. So have we got a open circuit secondary? Let's just check. No. Plug it back into the hoppy device. And we'll try and look at the input side to the bridge rectifier. I can see this board's going to have to come out again. I had every confidence. Okay, all change. We're going to have to service this radio on the external power supply because the IC has failed, which is a whatever it is. So 78S12. So unlike the 7812, this is a 2 amp device, which is what you'd expect on a CB, because the UK CB is going to draw about 1.5 amps. The way they've got this configured, it is only going to produce 12 volts, not going to produce 13.8. So I'm not sure how many watts this radio is going to produce at 12 volts, but I would suspect it's not going to be much above 3. So we're going to service this at power supply set at 12.4 volts, and we'll see how we go from there. So what we're going to do is simply click the negative lead onto the chassis and the positive onto the on and off switch. And hey presto, of course, the set's lit up. And somehow we will manipulate the channel knob to channel 20. We want to be on high power and we want to be on DX. So first thing I'm going to have to do is to make up a mic, unless we've got one kicking around on the bench. That's not one. It's amazing what's kicking around on the bench. That's not one. And that's not one either. Nope. Pause the video. Right, so I've made up a new mic and 5-pin expensive realigned plug, gold-plated pins. So we'll plug that in, and we can actually start, after all this time, on servicing the radio. So, better plug the test instruments in. Okay, so it's receiving. And it's transmitting. Good. So what we better do is start with that 10.24 reference oscillator. So we'll put the negative onto chassis. So I said before, when I've used this, it's just for convenience. I don't need an oscilloscope. It's just convenient as a frequency counter for this application. It's pin 3 of the MC145106 Motorola synthesizer IC. Okay, it's pin 4 on this one. It does vary. So 10.238 we've got, so that needs to change. Otherwise we're going to end up with lopsided receive. we go. We now have 10.24, and receive got obliterated doing that tune-up. Yep, 10.24, spot on. Okay, that's that done. So now we'll set the transmit frequency. So I'll go picture in. Are we on picture in picture? I can't tell. Yes, there we are. Picture in picture. So we're looking for 27.79125. 27.79168. So it's very high. I didn't check it before. I mean, we could have checked it before. It might have been because that was wrong. I'd rather have this toggling towards 6 rather than towards 4 because they drop naturally with age. It's just that tad high. I mean, where it wasn't out of tolerance. Anyway, there we are, 79128. That'll do nicely. Excellent. So now we'll tune up the transmitter. And by the looks of it, it's doing very well, especially as we're running the thing on 12.4 volts. It's doing 3.2 watts as it stands. Let's go back to that display. So the first coil is the wax filled one. That's fine. And we'll peak the next one. That was already correct. That wasn't correct though. We're now at 3.8 watts. I wonder if this has got some different component values to make it do more power on a lower voltage. Anyway, I'm not going to research it. So we're now 3.8 watts. 3.8 watts. 3.9 watts. Just won't quite do the 4. So that's 3.95 or something like that. So I'm going to put the spectrum analyzer on auto. See whether it picks us up. No. Just make sure I haven't pinched the pickup lead. Okay. 27. I'll have to stand up to see this. 27.79126. So there we are. That's our center frequency, which is what we're looking for. So with the mic keyed, we'll go up to see if the second harmonic at 54 and see whether that's in spec. There's our second harmonic. Measure. Whoa, that's not in spec. 42, 43. It wants to be up another 10. Now, have we got a coil in there? if there's a coil in there, that could be the 54 meg trap. Yes. Doesn't want to shift easily, I don't want to break the ceramic tool, so I'll use one of the phosphor bronze tools. That's got it to move. $55. No, still $42. Let's see which one's really affecting this. We'll just go back to that first one. Well, it's got it up to 50, but it's not. It's really on the borderline. That. Anyway, I'm sure the DTI or whatever they're called this week aren't going to come knocking at my door whilst we do a 6-minute on the air test with it sometime in the future. It may also change when the lids are on. Alternatively, you can use a low pass filter. So let's see what the power is now. It's now 3.8 watts, 3.9, but it's now quite warm. So that's transmit as far as that's concerned. We need to look at deviation. Turn the spectrum analyzer off. And we won't have the fan rumbling. Wallow. Are we tuned? That's awful. Wallow. Yeah, we are tuned. 1, 2, wallow. Very low, that. Good grief, that's full. Wallow. 1, 2, wallow. Going to check we're tuned on this instrument. Wallow. 1, 2, 1, 2, 1, 2, wallow. Wallow. 1, 2. Also helps if I put the camera back on the instrument I'm looking at. 1, 2. Not good. Wallow. 1, 2, testing. 1, 2. That's awful. Testing 1, 2, 1, 2. Testing 1, 2, testing 1, 2. 1, 2, 1, 2, testing 1, 2. 1, 2, 1, 2. 1, 2. Wallow. 1, 2, 1, 2. Wallow. 1, 2, 1, 2. Testing. Wallow. Wallow. Testing 1, 2, 1, 2. Wallow. 1, 2. Well, that's certainly quieter than I would expect. It's about. Well, let's do another whistle. Wallow. Wallow. It's only about 1.8 kilohertz, which is about where new sets are. Not expecting this to be like that. So I might have to look into the speech processing circuitry. Right, so let's have a look at the... Put that diagram away, and we'll have a look at the S meter. And I mean by that the RF meter. It should be in the centre of the red zone. Now we have it in the centre of the red zone. And on low power, should be doing 400 milliwatts. It's doing 350 milliwatts. Can we get it anywhere near it? We can. Spot on 400 milliwatts. So that's nice. Right. We'll move over to receive. I'm going to try a genuine DNT microphone on this before starting to delve into it later on. So let's see what the sensitivity is right now. So right now for 12 dB we are doing 1.35 microvolts, so it needs to come up a bit from that. We'll start with the detector and we'll just put a S9 signal on that. That's 100 microvolts. We'll look at that on the oscilloscope. Now that is all wrong. So either the detector's out or the IF's out. Okay. Not perfect. Let's look at the cyanide meter. I think first of all, oh my goodness, the squelch has come in. So the squelch preset must be pretty hard on. You know, I've gone and adjusted low power by mistake. What a fool. Sorted that back out. Of course there isn't a preset squelch on these, is there? The front end, where the sensitivities, is spot on. I wonder if that's been messed with. Now I'll look back at that detector. Oh, you know what we've not done? We've not set receive frequency. That's probably why it's all lopsided. Oh dear, oh dear. Right, we'll switch the signal generator to on but no tone. We need the Chinese signal generator as a marker oscillator. Oh, but it's miles out. And it's still on 10.695, which is kind of it. So, with that on 10.695, you can hear that musical note, I'm sure. And we need to null that. Actually, it won't quite go. Just need the signal generator was about 5 hertz out. There we are. We're spot on. Excellent. Right, we'll go back to an S9 signal. I've still got a kink in it. Just check these once again. I don't need to check the front end. So I've got a kink in it at high signal. Check with the RF gain. No kink. Kink. Oh well, we'll see what it sounds like on receive. I mean, who else would check that anyway? Okay, let's look at the cyanide reading. So for 12 dB cyanide, we now have 0.89 of a microvolt. For 10 dB, we now have 0.69 of a microvolt. And if it does 20, which it does, it's 3 microvolts. Right, we'll set S9. And that's the preset at the back there. Just like that. That's it. Now, I'll go and get a microphone. So looking at the circuit diagram, capacitors 78 and 80 directly couple the audio from the microphone. So we've got first transistor, then a 1 microfarad capacitor, and then we've got the second transistor and another 1 microfarad capacitor. Now if those were dodgy, we would have a problem. There's also an electrolytic capacitor there, which if that was leaky could change the way the transistor is biased, and the same applies with 79. So if I can find them, I think that changing 80, 78, 81 and 79 will improve things dramatically. And if it doesn't, well, we'll look somewhere else. Okay, so we've got audio back now. Hello, testing 1 2, wallow. So what we need to do is just turn that down now because it's far too loud. We'll go back to the standard replacement mic instead of the factory original mic. But it's one of those things, you know, you clutch at straws and you think, well, is that the reason? Testing 1 2, testing 1 2. Okay. So deviation, wallow. Bring back the little oscillator. Wonder when this last had some transmitted audio. Turn the monitor receiver off now. Hello, testing. Wallow. Wallow. That's it. Spot on. Now I've dropped one of them on the floor. So let's test what we took out. So this is supposed to be 1 microfarad. And it's short circuit. And this one's supposed to be 2.2 microfarads. And it's open circuit. And it's open circuit. Right, so that I wonder if someone's had a power mic on this and got something wrong, you know, and kind of blown up the audio processing. Just makes you wonder, doesn't it? So we've now got ourselves a nice working radio, which it's Saturday today, so on Tuesday we should get the power supply part. So we'll finish this at this point because the radio is finished, it's spot on, and I'll just shove it on an aerial. I won't aimlessly call 19 for a Roger. But we'll hold until the part comes to finish the power supply to do our on-the-air test, and then we can all see it in one piece properly. So that's working nicely. This is going to be fun, changing channel. If any of you have got a really smashed up DNT M40 and want to sell me the knobs, one niner, Roger. Oh, I was on low power. That really helps. One niner, Roger. Okay, so there we have the B40 living again, waiting for a part. They're not that expensive, it's just I had to buy 10 of them, so they won't be. They're about £1 each. It's still not too scary. So if I could do with 9 of these coming in for repair, needing that chip changing, and then I'll get my money back, won't I? So hope that was interesting. Even if it's not quite finished, the DNT B40 base station from 1981, and of course it's been turned out of a scrap set.